Palo Verde seed pods.
Well, we certainly use fingerprinting a lot in agriculture, but we've never looked at this particular species, this tree. Nobody has probably ever done much biology on it at all.
Prosecutors had circumstantial evidence linking Mark Bogan to Denise Johnson's murder, but they needed something more definitive. They knew they would have to prove that Bogan was at the crime scene, and the Palo Verde pods were their best chance. The scientists had no idea that their research would be the cornerstone of a murder case. The Arizona Sheriff's Department wanted to know if there was any way scientists could match the 2 seed pods found in the back of Mark Bogan's truck to the Palo Verde tree next to where they discovered Denise Johnson's body. But there were thousands of Palo Verde trees in the Phoenix area alone, and there had never been a DNA test on this type of tree.
We had to learn how to do the analysis so that we could say, do trees look different from each other in this species? Because what we wanted to know was not was this a Palo Verde tree, but could I match it to that specific tree?
The work on the Palo Verde pods proved to be long and tedious. It took months for Dr. Helenjaris to even devise a test he thought would work. And even then, he was frustrated.
In fact, a couple of times I'd sort of given up and said, well, this is too hard, I got other things to do. And then they would call me back each time and say, no, this is really important, we're not going to go to trial without this, will you try again? So we'd go back, and finally about the 3rd time or so, we really got it to work.
Dr. Helenjaris used what is known as a randomly amplified polymorphic DNA technique, or RAPID. This is a less common test than RFLP, the one used in searches for human DNA.
One of the great things about RAPIDs is that you're able to know nothing about an individual species or type of organism. You don't have to have any prior knowledge about it. All you have to do is get DNA, and the method works.
The test begins by removing the beans from their hard outer shell or pod.
Seeds have DNA both from the mother tree and other trees that would have pollinated it, so we need to get rid of those and just use the pod material, which will only have DNA from the mother tree.
The shells are put into liquid nitrogen, making them brittle and easier to grind into a fine powder. A chemical solution is added, and the DNA floats free, a sticky bundle of complex molecules. The sample amount of DNA from a seed pod is too small for analysis, so scientists increase the sample size by copying the DNA strand. They use a technique called polymerase chain reaction, or PCR. The copying process takes place in a DNA thermal cycler. Within a few hours, this technique multiplies the DNA millions of times. The DNA is then placed into various lanes of a gel with a dye added, and then subjected to an